Welcome to question 1 from the 2020 TMUA paper 2. The question asks us to find the complete set of values of k for which the line y equals x minus 2 crosses or touches the curve y equals x squared plus kx plus 2, and we're given 6 different possibilities for this set of values. Pause the video here and have a go at doing this for yourself. Okay, well let's start by thinking what we mean when we say that this line crosses or touches this curve. Indeed, this curve is a quadratic expression and the line is a linear expression. So if the line crosses the curve, then that means we'll have 2 points of intersection, and if it just touches it, then we'll only have 1 point of intersection. So how can we write that this line and this curve have 1 or 2 points of intersection in an algebraic way? Well, points of intersection of two curves is the same as having two solutions when we equate the expressions on the right hand side of these equations. So algebraically what we're saying is that there is at least one solution to the equation x squared plus kx plus 2 equals x minus 2. Okay, so what can we do with this? Well, if we move everything onto the left hand side and collect like terms, we see that this is saying that x squared plus k minus 1x plus 4 equals 0 has at least one solution. So this is exactly what we want to solve, and we want to find the complete set of k values for which this is true. So pause the video here and have a go at doing this for yourself. Okay, well how can we solve a problem like this? Well, what we have is a quadratic expression, and we can relate the number of solutions to a quadratic expression to the discriminant, and in particular if a quadratic equation has at least one solution, then that tells us that we need to have the discriminant be greater than or equal to 0. But what is the discriminant? Well, the discriminant is this coefficient squared minus 4 times this coefficient times this coefficient. So we need to have k minus 1 squared minus 4 times 1 times 4 greater than or equal to 0. Okay, well how can we solve this? Well, we can multiply 4 and 1 and 4 together to get 16 and move that onto the other side of this inequality. So this is just the same as k minus 1 squared is greater than or equal to 16. And when will that happen? Well, 16 is 4 squared, so this will be true if k minus 1 is greater than or equal to 4, or if it's less than or equal to minus 4, because minus 4 squared is also 16. So those are our two possible cases. And then if we add 1 to both sides of these inequalities, we see that we either have k less than or equal to minus 3 or k greater than or equal to 5. And since we've followed a series of if and only if steps, this is the exact set of values for which this equation has at least one solution, which is exactly the case where the line and the curve either touch or cross each other. And if you look back at the options at the start, this is exactly option E, so that's our answer.